In the frigid, crushing depths beneath the Arctic ice, an ancient creature drifts through the darkness. Fishermen who encounter them call them ghosts. Their movements are sluggish, their eyes pale and almost lifeless, often with a repulsive, worm-like parasite dangling grotesquely from the cornea. When accidentally caught, their smell is so overwhelming, a rank odor of urine, that fishermen recoil. Their flesh is toxic. Sled dogs that eat it become shark-drunk, suffering convulsions, explosive diarrhea, and ultimately, death. But these sharks are more than just unsettling. They seem to defy the very rules of nature. They swim at a crawl, yet are considered a top predator. They are the only shark that can withstand the year-round freezing darkness of the deep Arctic. And then there is their age. They can be so ancient that there are individuals swimming in the ocean right now that were alive before Columbus voyaged to the Americas, before Michelangelo painted the Sistine Chapel, while the Aztec Empire was still thriving. Scientists estimate some could be well over 500 years old, making them the longest living vertebrate on Earth. For centuries, its secrets have been locked beneath the ice. But now, that black box is beginning to open. Why is the Greenland shark so toxic? How is it possible that it's a top predator? And how in the world does it live so unbelievably long? Greenland sharks are giants, growing up to 7 meters long and weighing over 1,000 kilograms, comparable to a great white. But where the great white is a torpedo of muscle and speed, the Greenland shark is a slow-motion phantom, barely breaking 3 kilometers per hour. So how can this sluggish ghost possibly be a top predator? How could it ever dream of catching an agile seal? For years, scientists were baffled. While we know they scavenge, there's strong evidence they also actively hunt. The leading theory is as cunning as it is chilling: they are ambush predators that hunt sleeping prey. Think about it from a seal's perspective. Its greatest danger is a polar bear on the ice above. So, it often chooses what seems like a safer option, sleeping in the water column. But what is safe from above is tragically vulnerable from below. The Greenland shark, guided by its powerful sense of smell, can drift silently upwards from the abyss, closing in on the sleeping seal before it can even register the threat. And if the prey is too large to swallow whole, the shark employs a gruesome tool. Its bite is like a giant, rotating hole punch. The upper teeth are sharp and narrow to anchor the shark, while the broad, razor-like lower teeth gouge out a perfect, circular chunk of flesh. Beluga whales have been seen swimming with these perfectly round wounds, the telltale sign of a Greenland shark's attack. Their teeth are so brutally effective that for centuries, Inuit societies crafted cutting tools from their jaws. But this ambush strategy relies on stealth and scent, because for this predator, vision is often not an option. In fact, its eyes are home to one of nature's most bizarre and horrifying afflictions. Nearly every adult Greenland shark is blind, thanks to a parasitic copepod that latches directly onto their eyeballs. These aren't tiny organisms, they can be several centimeters long, dangling from the shark's eyes as it swims. It's believed these parasites permanently damage the cornea, leaving the shark capable of only sensing basic light and shadow. So how does a blind hunter navigate and find prey in the eternal darkness of the abyss? It relies on a suite of other, far more powerful senses. Up close, in the final moments before an attack, it uses a superpower all sharks possess. Its face is covered in tiny black pores called the ampullae of Lorenzini. These pores are filled with an electrically conductive jelly that can detect the faint bioelectric fields generated by the muscle contractions of all living creatures nearby. This allows the shark to see its prey's heartbeat and movements from a meter away, even when it's completely hidden. But to find prey at longer distances, it uses its primary weapon, an incredibly acute sense of smell. While the Greenland shark has one of the smallest brains of all sharks relative to its body size, there's one major exception: the olfactory bulbs, the parts of the brain associated with smell, are enormous. This indicates a profound reliance on scent to interpret its world. Its large nostrils draw water into highly sensitive organs that can detect a single drop of blood from kilometers away, guiding it through the darkness towards its next meal. Guided by these powerful senses, the Greenland shark travels to depths where other creatures would be instantly crushed or frozen. It has been tracked as deep as 2,900 meters, the midnight zone, where sunlight never penetrates and the pressure is immense, over 290 times greater than its sea level. So how does it survive? Part of the answer is that unlike most fish, sharks don't have a gas-filled swim bladder to regulate buoyancy. Gas compresses under pressure, which would be fatal. Instead, they use a massive, fatty liver, which isn't affected nearly as much by pressure changes, allowing them to travel between the abyss and the surface. But the true secret to surviving the crushing pressure and the sub-zero water temperatures is a chemical superpower. The shark cells are saturated with a compound called TMAO. This molecule acts like a microscopic shield, protecting the shark's proteins from being distorted by the extreme cold or crushed by the immense pressure. It stabilizes the proteins, allowing them to function in an environment that would destroy most other forms of life. The deeper a creature lives, the more TMAO is found in its cells. And the Greenland shark has one of the highest concentrations ever recorded. This chemical shield is also the answer to another mystery: why the shark is so toxic. The same TMAO that protects its cells metabolizes into trimethylamine, causing the dangerous shark-drunk symptoms. And it's also what counteracts the high levels of urea in its blood, the urea that stops it from dehydrating in salt water, and also happens to make it smell like pee. So, with stabilized proteins and perfectly balanced bodies, Greenland sharks drift through the abyss, unbothered, moisturized, and in their lane. They are so well adapted, in fact, that they can exist in this environment for centuries. The first hint came in 1936, when a tagged shark was recaught 16 years later. It had grown just half a centimeter per year, a glacially slow growth rate. Scientists did the math: at that rate, a 6-meter shark would be ancient. But proof was impossible to find. Until now. Recently, Danish scientists found the key hidden in the shark's own eye. The proteins that make up the eye's lens remain unchanged throughout an organism's life. By analyzing the levels of carbon-14 in these proteins, an isotope whose atmospheric levels spiked dramatically during the nuclear bomb tests of the 1950s, they could finally date the sharks. The results were astounding. The largest shark they studied was determined to be 392 years old, plus or minus 120 years. This means it was, at minimum, 272 years old, and at most, a staggering 512 years old. They also discovered these sharks only reach sexual maturity at around 156 years old. How is this possible? One explanation is that glacially slow metabolism. A slower metabolism produces less oxidative stress and cellular damage over time, less wear and tear. It's a pattern seen in other long-lived animals, like the 200-year-old bowhead whale or the Galapagos tortoise. But the deeper answer may lie in its DNA. The Greenland shark's genome is enormous, more than twice the size of ours, and over 60% of it is made of jumping genes. These genes can move around the genome, and researchers hypothesize the sharks may have hijacked their machinery to duplicate genes involved in DNA repair, counteracting things like cancer. Ultimately, the reason why they can live so long comes down to a simple evolutionary reality. Animals that face high risks, like predation and disease, have to live fast and die young to pass on their genes. But animals with low risks can afford to delay everything. And this just shows that not much bothers the Greenland shark. Not many predators, not many diseases. The Greenland shark only has to deal with the crushing weight of time.